cover is something called as inverse function. Now, we all might be already aware about what exactly is inverse function. Now, as per mapping, if you see x maps to f of x, let's say if my domain is x and range is y, if any function that, let's say, converts input to output, that's your original function. But if any function that is like converting output to input, that you can refer it as inverse function. So the certain, like, basic things that we need to understand firstly is that how do we find inverse? How do we find inverse? So first, let's talk about in terms of mapping. So let's say mapping is 1, 2, 3. This is my x value, and my y values, let's say 4, 5, 6. So if one x is mapped against one y value, then only you can find inverse function. So let's say if I have got here, the domain is 1, 2, and 3, and the range is 4, 5, and 6. As per my definition, now when you have an inverse function, you showed like f to the power minus 1 x, or sometimes it is written as f to the power minus 1 itself. That is understood as f inverse. In f inverse, my mapping will be switched. So it'll become 4, 5, 6 will become my domain, and my range will become 1, 2, and 3. So 4 is going to be mapped against 1, 5 is going to be mapped against 2, 6 is going to be mapped against 3. So what is really interesting here is that you see the domain has switched to range and range has switched to domain. This is very important aspect of the inverse function. Now, when you're looking at simple, like, conjecture, like for example, let's say here, if I look at f of 1 is 4, very simple is f of 1 is 4. When I plug in x is 1, y value is 4. But if you look at this, f inverse function, f inverse of 4 is 1. So this is a very interesting conjecture you're getting. So I can say that if f of 1 is 4, then f inverse 4 is 1. So it means that if I bring in, like you can say that in lame term, if I bring into the other side, f becomes f inverse. So f inverse of 4 equals to 1. And this is one of the very important step to solve many critical problems. Now let us say if you got f of a equals to b, then a is going to be f inverse of b. This is one step that we got to remember, which is like clearly being evident from here, like now as I've shown here. If you have got f inverse of a is b, then a equals to f of b. So it's if you bring in inverse to the other side, it becomes a function. You can, like, these are some, no, like, textbook will talk about it, no there is no structure to this kind of formulas, but these you can remember for shortcuts. These are some of the shortcuts which IB recognizes, so you can use these shortcuts. So let us say sometimes you'll get, I'll just give an example is if you got f of x is x cubed plus x squared plus 5x plus 3. And right now I haven't taught you how to find inverse and all, but suppose, let's say, if they ask us to solve f inverse x equals to 4, or let's say f inverse x equals to 1. Now, instead of finding f inverse, you can just use, let's say you have to solve this equation. So you could have just done x is f of 1 straight away. So if you bring f inverse this side, x is f of 1, which is my answer will be 1 cube plus 1 square plus 5 times 1 plus 3. So you get 1 plus 5 plus 1 plus 1 plus 5 plus 3, which is basically 10. So this is how this particular formula is so effective. So I would recommend that you remember this logic. If f of a is b, a is f inverse b. If f inverse a is b, then a is f of b. This has been assessed several times, and a lot of times students don't know how to do this. So that's why I'm explicitly highlighting this particular concept so that you remember these very, very important formula. Now, coming to the process, like as I had told you, if it is 1, 2, and 3 mapping, it is, let's say, 3, 4, and 5, for example. I'll just take the previous one itself, 4, 5, and 6. So this is 4, 5, and 6. So 1 was getting mapped with This 2 was with 5, 3 was with 6. So if I just show it here, let's say the coordinates that we have, 1 comma 4 is somewhere here. Let's say 1 comma 4 is here, 2 comma 5 is, let's say, here, and 3 comma 6 is, let's say, here. And now when I'm doing inverse mapping, so inverse mapping is 4 is 4 comma 1, 5 comma 2, 6 comma 3. So 4 comma 1 is somewhere here, 5 comma 2 is somewhere here, and 6 comma 2 is 6 comma 3 somewhere here. So what you'll notice is that this mapping that you've drawn is actually exactly symmetric about, or like, its reflection across y equals to x line. So if you reflect these coordinates, like for example, if you have got 1 comma 4, which is this coordinate, now if you reflect here, it'll become 4 comma 1 and vice versa. So whenever you have an inverse function, and if you want to, suppose if you have been given a function and you want to draw inverse of it, you just got to do one thing, is you just got to reflect across y equals to x line. Now, you might be already aware about. So let's say if I'm showing here a function, for example, let's say this is my y-axis, this is x-axis, and I'm showing a function, let's say this is the function which is out here. Now, if I wanted to reflect this across y equals to x line, first you draw y equals to x line. So y equals to x line. Now remember that whenever you reflect a graph in y equals to x line, very interesting thing is that all the x properties will become y properties and vice versa. Now, what do I mean by that? When you say that, domain will become range now. Range will become domain. Vertical asymptote become horizontal asymptote. Horizontal asymptote will switch to vertical asymptote. So x-intercept now will become y-intercept. So suppose this was cutting at -1. Now your y-intercept will be -1. If this was cutting here at, let's say, 0 comma 2, this will cut at 2 comma 0. And very important is that if at all the function and its inverse graph, they will intersect, you'll notice that if I would have drawn a proper y equals to x function, this is how it will look like. So it is like a symmetric, so y equals to x is like a mirror line. So this graph, this point will be reflected somewhere here, this part will get reflected here. You will notice that if at all function and its inverse, they intersect, they will be intersecting along y equals to x line. This is once again a very important property. So this is about, up till now, what we have touched bases of what is basically an inverse, how to graph it, what is the general understanding about it. Now from here onwards, we'll be working on how to find out inverse and how to understand in depth the properties of inverse, you can say. So now one of the very important question that comes is like, and you'll keep getting this in HL or SL, is that, well, does inverse exist for all the kind of function? And is it like, can you demonstrate this? So let us say if you have got a function, I'm just taking a simple example. Let's say I'm taking a parabola, which is y equals to x squared function. So if I find out inverse of this function, like according to the graphical presentation, when you draw the graph of this, like which is reflection in y equals to x line, you will notice that you're getting this as an inverse. So this part, which is getting reflected out here somewhere, I'll just take a different color. So this is getting reflected here. This part will get reflected here. And this part will get reflected something like this. So now you will notice that the inverse function, so I'm just reminding you about the vertical line test, that vertical line test is to affirm whether a given relation is a function or not. So if you draw a vertical line and it cuts the graph at only one specific point, for example, here if I draw a line, it cuts at the graph at only one particular point, then it is a function. Unfortunately, when you call f inverse, like inverse function, here this is not being true. So if you look at, there is a line, vertical line, that is cutting at 2 points. There is a vertical line, if you draw, that's cutting at 2 points for the inverse function. So what does it mean is that my inverse that I found, or that I just drew, It's not a function. So they basically calling inverse as a function will be a problem here because it is not a function, because it's failing vertical line test. So what's wrong with this and what's wrong with our fundamental? Remember that inverse, now from here, you got to remember a rule, or you can say this like a checking, that what kind of functions will have an inverse. Now remember that inverse exists for only those functions which are strictly increasing or strictly decreasing. Now this is once again a puzzle, like what is increasing function? Now remember that increasing function is something which has got always a positive slope. You can see like if you draw a tangent at any point, it is always positive slope. What about the decreasing function? Is like whenever you draw a tangent, it is always going to cut here at one specific point. So increasing function or decreasing function, which is, this is both are increasing here. Now decreasing function is something like here. So if you draw a line which is going to cut at like, which will be like a negative slope. So whenever you have a function that is you either increasing or decreasing, will have an inverse. Now there is a test that is referred as horizontal line test that helps us whether the function is increasing or decreasing, or like, I mean, strictly increasing or strictly decreasing. So horizontal line test categorizes whether the inverse will exist for the function or not. So suppose if you got a function, let's say this is a function, and if you find out, let's say the inverse of this function, if I draw a horizontal line and if it cuts the graph at more than a point, then inverse will not exist for this function. So horizontal line test that you're talking about is something that tells us whether the inverse will exist or not. So horizontal line test here, guys, you'll see that this is cutting a 2 point. Hence, inverse won't exist. Hence, inverse won't exist for given domain. So if a function is purely increasing like this, if you see that horizontal line cuts at only one specific point, hence inverse will exist. If a function is purely decreasing like this, inverse exists because it cuts at only one point. So the question is that, will the inverse not exist for this function for all the x values? No. Now, if you have a function, I can just take, let's say, instead of taking entire domain, let's say I can take only the left side of the graph and the function is 1-to-1 here. Or you can say the function passes the horizontal line test. So here, you can cut this part of the graph and inverse will exist. So if I reject this left-hand side, inverse exists for the right side of the graph. So you have to be very careful when you're talking about the inverse existence. It will exist only if the function is 1-to-1. It means that 1x is mapped against 1y value only. And secondly, it passes the horizontal line test. So these two reasonings you're going to give in case if they ask you to justify whether the inverse exists or not. So this is very important. And it has to be understood carefully. Okay, so the next part is basically, I'm going to take 3 to 4 examples to demonstrate how do we find inverse, how do we tackle the questions on inverses, like certain questions which involve domain and range, restriction of domain and range. So the first question is very simple. I'm going to take a simple question is f of x is, let's say 3x minus 7 upon x plus 5. Now I'm assuming that you know the concept of like horizontal vertical asymptote before you attempt this question. So the first thing that you'll notice here is that when you write down the question is that check if inverse exists for this function or not. And we can do that by, if you have sketching, generally there'll be follow-up question in this. So I'm creating follow-up questions. Like first is find horizontal asymptote, vertical asymptote, roots, y-intercept, x-intercept is same as roots. So don't worry about this. Second is sketch and justify if inverse exists. If inverse exists. Third one is sketch f inverse x and fx on the same grid. and also find where they're intersecting. Also find where f of x and its inverse intersect, if at all. Third is fourth is find out an expression for inverse. And state its domain and range. State its domain and range. So this is like, these are the follow-up questions that we have. So I'm just starting with horizontal, vertical, asymptote, roots. So when you're talking about, let's say the function, let's say here, if I find out the roots, it's going to be x equals to 7/3. How I got it? By plugging y as 0, solving for x, you get x as 7/3. So that's x-intercept is at 7/3, 0. Y-intercept is at -7/5, 0, -7/5. Because if you plug in x as 0, you get that. Vertical asymptote is x equals to -5. Horizontal asymptote is y equals to 3. Y equals to 3 is the horizontal asymptote, because you're like you can say that you're taking the coefficient ratios. Or here, remember that in any structure question, if your equation is of the form ax plus b upon cx plus d, the horizontal asymptote is given by the coefficient of x ratios, which is y equals to a over c. So we've got till now, and now next one is we've got to sketch and justify if inverse exists. So when I'm sketching this question, like let us first draw a grid. So here what we have is the grid, and now we got to draw the proportionate, let's say this is x equals to -5 is the vertical asymptote, y equals to 3 is horizontal asymptote. Then you got the roots at 7/3, 0. So 7/3, 0 is the roots. Y-intercept is -7/5, 0, 0, -7/5. So this is the y-intercept. So obviously you can see here that this is a graph which is going to be here like this. This side, the graph is going to run parallel to vertical asymptote. Since you have got the domain of this question, you can see only at -5 is undefined. So here you'll have the second part. Lots of times students don't draw here and they forget about it. That cost you like half the marks. So remember that if the function, if I ask about the domain of this function, it is simple, right? So x belongs to real numbers. X should not be -5. And range is y belongs to real numbers. Y should not be 3. So this is the simple explanation about the domain and range. Now, what does it mean is that only at -5 function is not defined. So it means that there exists a graph that is to the left or right of the function, right of the vertical asymptote. So if you miss out here, you get wrong. Now, some people will draw the answer out here. Let's say if you draw here, you're violating that there is only one root. So there can't be a graph out here. So remember that these are some of the shortcuts or quick checks you make in order to get the correct answer. Now, once you get this, sketch is here. Check if inverse exists or not. We can clearly see that it passes the horizontal line test and the function is 1-to-1. More important is to use the word 1-to-1 as the keyword, 1-to-1 function. So the function inverse exists here and the function is 1-to-1, hence it will have an inverse. Go on to the next part is sketch at f inverse x and fx on the same graph. So when you're sketching this, now I'll become a little, I'll do the sketching towards the end. But there are 2-3 things that we need to do. Now find out an expression for f inverse. So to find inverse expression, you interchange x with y because your domain is switching as range and range is switching as domain. So suppose if my function is 3x minus 7 upon x plus 5, you interchange x with y. So this will become 3y minus 7 upon y plus 5. So you get xy plus 5x equals to 3y minus 7. Now collect the y terms together. So xy minus 3y equals to -7, -5x. I got these things here and I got y to the other side. So you get y, if you take common, you get x minus 3 is -7 minus 5x. and you get y is -7 minus 5x over x minus 3. This can further be written as 5x minus 7, 5x plus 7 upon 3 minus x. That's also is okay. So any of the expression, that is fine. Now the question here is, and state its domain and range. Remember that when you're finding the inverse, its domain and range switch. So now you could have predicted that looking at here itself. So for inverse function, I'm just going to use like different colors. So f inverse x is basically 5x plus 7 upon 3 minus x. You can look at this expression and tell the answer, or you can just look at this. So domain here is x belongs to real number, x should not be 3. Range is y belongs to real numbers, y should not be -5. And that I'm getting through here straight away. So x is now y and y is now x. The question is here, this part is sketch f inverse and fx on the same graph. So when you sketch, you basically reflect in y equals to x line. So this part, now your vertical asymptote that was -5, that's going to become horizontal asymptote, x equals to -5. And the one which was vertical asymptote, horizontal asymptote, now it's going to become a vertical asymptote, which is going to become x equals to 3. So x equals to 3. So now this part of the graph goes gets reflected somewhere here like this. So it'll be something like this, and this part that is out here will come now out here. So unfortunately or fortunately, you can see that this is not intersecting. The original functions inverse, they're not intersecting at any point, as long as we are making any mistake. So let us just check if the function and its inverse are intersecting or not. Now, as I have told you, the function and its inverse intersect only when along y equals to x line. So you don't need to actually equate f inverse x with fx always. I mean, you can do that here. I will equate this with this and get a complicated quadratic and solve it. Or you could just do is equate y equals to x instead of this function, which is here, instead of f of x, since they intersect along y equals to x line, you can just replace y with x and you solve. So 3x minus 7 upon x plus 5. And if you cross multiply, you'll get x squared plus 5x. So I'm not equating, you can see like, suppose it's like this. Suppose if the function, this is out of the context. Suppose if the function is inverse, they meet at along this line. So either I equate these two functions and its inverses, or you can just equate the one of the function with y equals to x line. So I'm equating one of the function with y equals to x line, and I'm trying to find out if it has got any root. So x squared plus 2x and plus 7 equals to 0. So you can see here that I'm not getting any distinct root, because if you do b square minus 4ac, it's coming negative, because if you do that, 2 squared minus 4 times 1 times 7 is less than 0. Hence, that is justifies. And basically, these are the type of questions that are like, somewhere around 13 to 15 marks. So you got to be careful on how to tackle each and every aspect. And I hope this is clear. So now this was the question where you did not have to restrict any domain and all. The function was defined where like because it fulfilled horizontal line test, the function was one-to-one function. But there are certain type of question, like for example, if I have got a question like -x squared plus 6x plus, let's say 10, -x squared plus 6x plus 10, and I wanted to check if inverse exists for this function or not. You have to justify that by sketching the graph, and then you, in case if it exists, you have to find out the largest domain such that x is greater than or equals to a, where inverse exists. So in case if it doesn't exist, for this value, it will exist. Let's see what's that value. So before I go to this question, like the first part, this is the second part, and after the third part is find expression for an inverse for the part B. So before I go ahead on this, I would sketch this graph, and I prefer like, making in perfect square form always, like if you wish to sketch x squared minus 6x plus 10, you can keep it outside. And now you do x squared minus 6x plus 9 minus 9 and plus 10. This I'm making perfect square. The presumed knowledge for this part is you should know perfect square. So x minus 3 the whole square plus 9 plus 10. So negative x minus 3 the whole square plus 19. So this is the expression, negative x minus 3 the whole square plus 19 for this particular quadratic. Now, what does it mean is that it's, if you look at this vertex of this graph is at 3 comma 19. So the vertex is 3 comma 19 here. And the graph is going to cut y-axis at 10. Y-intercept is 0 comma 10. I am getting that by plugging x as 0 here. And it's a sad face graph. So since coefficient x squared is negative, it's a sad face graph. Now you notice here that your graph actually does not have an inverse because it fails horizontal line test. So then you just simply say in the first part that inverse won't exist because it fails horizontal line test and it is not one-to-one function. Now comes the second part. They're saying that for x is greater than a such that a gives the largest domain and where inverse will exist. So what I can do is remember that in any quadratic, generally you either restrict the left side of vertex or right side of vertex. Since here they're saying that you are taking x greater than or equals to a, means you're keeping this side and you're deleting this side. So, and also it should give me the largest value, like the domain should be largest for that function. So yeah, I could have just see, I could have restricted from here also. Like for example, I could have restricted from x greater than or equals to 4 also. I can take only this part of the graph, but in that case, you're cutting down this domain. So if I erase this part of the graph, my function is one-to-one still. But when is the largest domain? When I take right from the vertex onwards. So if I take x greater than or equals to 3, my inverse will basically exist. So this is something which is a very like general question. When x is greater than or equals to the x coordinate of vertex, that's where the inverse will basically exist. So you can see the red part now is one-to-one function because it passes the horizontal line test now. So you can find inverse for this function. So now let's do the expression for f inverse x. So f inverse, so a value that I wanted to do is 3. Generally, a is nothing but the x coordinate of vertex, because either you take left side or you take the right side of vertex. If they would have said take x less than or equals to a, then you would take a as still 3, but you're taking basically retaining the left side of vertex. So out here in this question, I have retained the right side of vertex, and my question is basically now I have to find out inverses x minus 3 square plus 19. Remember one of the important thing, when you're finding inverse for a quadratic, don't ever use this as general form. Try to always use the perfect square form, because here there are two x's and you will not be able to make like, you know, what do you say, the x the subject, y the subject easily. So interchange x with y here in the perfect square form itself. So y minus 3 the whole square plus 19. Then you make y minus 3 the whole square subject, which is x minus 19. And after that, we get negative is here. So y minus 3 the whole square equals to 19 minus x. And then you make y the subject. Y minus 3 is going to be plus or minus root 19 minus x. And you take y as 3 plus or minus root 19 minus x. Now, you're seeing here that you got two expressions. One is plus, another is minus. So one of the expression is with plus, or other one is like 3 minus root 19 minus x. So generally, what works the best is, like, this is my assumption and my own way of thinking, is that if you retain the right side of vertex, you take plus out of these two signs. If you retain the left side of vertex, you could have taken minus for this side. So for inverse for this side will be y equals to 3 plus root of 19 minus x. And if you had retained this part, inverse for this side will be 3 minus root 19 minus x. My correct answer is this one, which is the plus. So this is how you find out the inverse. And now you need to always specify what's your domain and range for this inverse. So when you find out the domain for this inverse, basically domain for this is like same as the range of this function, which is y less than or equals to 19. So original range was y less than or equals to 19. Now that becomes the domain. So x less than or equals to 19 for this function is my domain. And range is x greater than 3 domain is x greater than or equals to 3 for the original function, my range for this will become y greater than or equals to 3. So this is all about the, like, such kind of questions where your inverse is not defined and you have to find inverse. And this is more or less the standard level questions itself, like little in the HL core category, but these questions can be assessed in SL and HL both.